Aloha. This is an online lecture for October 30th, Wednesday, Math 1123 Introductory Statistics by Dr. Lee. In this online lecture, we are going to review the problems from the second test. Problem number 1. Find a regression line to show the relation between the two variables x and y in the table. Follow the steps below. The first problem is to find the means x bar and y bar. And here is the table. You're looking at x variable here and y variables. To find x bar, which is the average of x variable. And here we have 3 pairs of data point. And if you sketch this point, here is your x variable, x-axis, y-axis. Here's 0. When x equals 0, you have 1 for y. x1 and y2, 1, and 2. When x equals 3, 2, and y equals 3. So we clearly see that we have 3 points, right? And eventually you want to find a regression line, which is actually this straight line. And to find the x bar, you have to average these 3 numbers, right? Add them up, 0 plus 1 plus 2 divided by how many variables? 3 variables. 0 plus 1 plus 2 equals 3 divided by 3, which is 1, right? And y bar, again, add them up. 1 plus 2 plus 3 divided by the number of variable 1, 2, 3, right? 3. 1 plus 2 plus 3, which is 6 divided by 3 equals 2. So we found x bar and y bar. Find the standard deviation S of x and S of y. First, let me remind you of the formula for standard deviation. S equals square root summation x minus x bar squared divided by n minus 1, right? So S of x square root, first variable minus x bar. First variable 0 minus x bar squared, right? Squared plus, this is summation, right? So 1 minus 1 squared plus 2 minus 1 squared divided by n minus 1, which is 3 minus 1 equals square root. This is negative 1 squared, right? Which is 1. 0 squared, 0. 1 squared, 1. Divide by 2, right? So that we have square root 1, which is 1. S of y, again the same thing. The first variable, 1 minus, this time y bar is 2. Mean 2 squared. 2 minus 2 squared, 2 is the second variable, and minus y bar plus third variable 3 minus the mean 2 squared divided by 3 minus 1, right? N minus 1. Here we have 3 variables or 3 data points, right? Again, this is negative 1 squared. Negative 1 times negative 1, negative, negative, positive, and 1 times 1, 1. 0 squared, 0. 1 squared, 1 divided by 2. Again, square root 1. So we have S of x, the standard deviation for x is 1. Standard deviation for y is, again, 1. Find the correlation coefficient R. To find R, we can use a formula summation c sub x, c sub y divided by n minus 1. Then first we have to find c sub x and c sub y, right? Okay. So we can draw here this of x and this of y, this of x and this of y. How can I find this of x? First, this of x is the variable x, your variable x minus x bar divided by standard deviation for x. And this of y, the variable y minus y bar divided by standard deviation for y, right? So here this of x is the variable 0 minus, what is the mean? 1 divided by standard deviation 1. 1 minus 1 divided by 1. 2 minus 1 divided by 1. Again, for this of y, the z-score for y variable, 1, the variable 1 minus y bar 2 divided by the standard deviation for y, 1, right? 2 minus 2 divided by 1, 3 minus 2 divided by 1. So that we have z-scores for x variable and y variable. The first one, negative 1. This one, again negative 1. For the second x, second variable, x, which is 0. For the second variable for y, equals 0. This one, 1, and 1. So then now we have this of x and this of y. Again, 3 pairs, right? Then let's find the correlation coefficient. This is summation. Summation this of x, this of y. This means sum up this of x times this of y. So for the first pair, negative 1 times negative 1 plus second pair, 0 times 0 plus third pair 1 times 1 divided by n is the number of data point, 3 minus 1. Negative 1 times negative 1, 1, 0 plus 1 divided by 2. Therefore, 2 divided by 2 equals 1. Now find the regression line. So how can I find the regression line? Basically, this is a line equation, right? So that it must have a form of y equals a plus bx, right? And what is a? A is y-intercept. Y-intercept. And b is the slope. Okay, then let's find these two constants. Okay, b, first let's find b. b equals r times s of y divided by s of x. What is r? r we just found, which is 1. S of y 1, s of x 1. So that we just found the slope b equals 1. And then for a, basically this regression line is passing through the mean x and mean y, meaning that if you plug x bar and y bar, this equality should hold. So that you can find a by plugging x bar and y bar. So y bar minus b x bar. Here y bar is the mean for y, which is 2, minus b equals 1, x bar 1. So 2 minus 1 equals 1, right? So we just have found a and b, which are both are 1s, right? Very simple. 1 plus x. Therefore, my regression line is y equals 1 plus x. Okay, second problem. General card. Okay. The general cards are used to test whether people can read mind. A deck consists of 5 cards, each with a different shape. A card is drawn and the person guesses the shape on the card. The drawn card is returned to the deck and the deck is shuffled before the next card is drawn. We want to count how many correct guesses a potential psychic makes in 2 trials. What is the probability that the person gets 1 or more answers correct? So first, this is a binomial probability, right? How can I know binomial? First, the number of trial is fixed. Where is the number of trials? 2, right? 2 trials. And second, there are only 2 outcomes. Here, either the guess is right or wrong. So here the success is the answer is right, correct? The failure is the answer is wrong. And how many options do we have? We have 5 different cards, and only 1 out of 5 is the correct answer. So my success probability P is a constant, which is 1 out of 5. So here my N equals 2. The probability of success P is 1 out of 5, which is 0.2. And the question is, what is the probability that the person gets 1 or more answers correct? So here my X, the number of successes, is 1 or 2, right? So if you write this with the probability notation, probability of my variable X is between 1 and 2. Again, you can rewrite it with binomial notation. Binomial of your N is 2 and P, which is the probability of success, 0.2, right? And your X is 1, between 1 and 2 inclusive. Since this is OR, which is union, right? Union, union. So that you can rewrite this as binomial 2.21 plus binomial 2.2 and 2, right? Now think about how many cases you can have. So we have 2 trials, and the question is how many answers are correct? 1 or more, right? 1 or more. So there are 3 cases. The first guess is right, second guess is wrong. And the first guess is wrong, the second guess is correct. And the both answers are correct, right and right. For the first case, the first one, success, the probability of success is 1/5 times. The second one is wrong, 4/5. Why? Because the probabilities of success and failure, those sum should be 1, right? The maximum 1. So if the probability of success is 1/5, then the probability of failure is 1 minus 1/5, which is 4/5. In second case, the first answer is wrong, second answer is correct. So first, the probability of failure 4/5 times the second one, probability of success 1/5. The last case, both answers are right, correct. So 1/5 times 1/5, right? So the first one, 4/25, second 4/25, third 1/25. And so that if you find binomial 2.21, what is this case? This one, right? No. This one is, one answer is correct, right? So these 2 cases, 2 times 4/25 plus 2 answers are correct, right? Out of 2, right? Which is 1/25. Therefore, 8 plus 1 over 25. 9 over 25. However, you can simplify this problem like, how about we use like 1 minus the probability that two answers are wrong. That means one or more answers are correct. So this is actually is the same as 1 minus probability that both answers are wrong. Right? Then this is 1 minus probability of failure times probability of failure, which is 1 minus 16 over 25. Again, you will get 9 over 25. Right? This is the end of second problem. And number 3, let's see, where is it? Right here. Okay, number 3, roll 2 dice. One die is red, the other one is blue. Assume that each side of each die is equally likely to appear face up when rolled. Consider the following 3 events. The first event, event A, the sum of 2 dice is 9. Event B, you roll even numbers, 2, 4, 6 on the red die. Here, this is red die, right? Event C, you roll a 4 or a 5 on the blue die. Okay. First problem, list all the possible outcomes of event A. What is event A? The sum of 2 dice is 9. Can I say 1/8? No, because this die, each die has 6 sides, right? So I can start, well, from maybe 3, 6, 4, 5, 5, 4, 6, 3. This one, the first entry is, let's see, red, and this one is blue. Again, red, blue, red, blue, red, blue. Then some of you guys might ask, oh, this one and this one are the same. No, actually not. Why not? This one, you roll 3 on the red die, 6 on the blue die, right? This one, 6 on the red die, 3 on the blue die. So these two cases are different. So we have these 4 outcomes, right? And the next problem is, what is the probability of event A? So P of A, the probability of A, and we have 4 outcomes. Out of how many? We roll 2 dice. So all the possible outcomes. The first die has 6 sides, and second one has 6. Therefore, all the possible outcomes, the number of all the possible outcomes is 36. 4 out of 36. 1/9. And what is the probability of event B and event C? And means intersection. In other words, find probability of B intersection C. Probability of B intersection C. Well, this is the same as probability of B bar C times probability of C. And this B bar C is the conditional probability. However, if B and C are independent, event B and event C are independent event, then this P of B bar C is the same as P of B. Why? Because C doesn't do anything on B, right? The event C does not affect event B. So this becomes probability of B times probability of C. Only when if B and C are independent. Right? Okay. Then what is the P of B? Again, the event B is what? You roll even number 2, 4, 6 on a die, on red die, right? So 3 numbers out of 6, right? So probability of B is 3 out of 6, right? Event C. What is the probability of event C? You roll a 4 or a 5. So 2 numbers out of 6. 2 out of 6. Okay. So P of B is 3 over 6. P of C is 2 over 6. Therefore, the probability of B intersection C is 2 times 3, 6. 6 times 6, 36. So that's 1/6. Find the probability of event B or event C. Let's see, I can move it a little up. So probability of B union C, or is union, right? Union equals P of B plus P of C minus P of B intersection C. And I mentioned that you should not forget this part. Why we have to subtract P of B intersection C? Because by adding these two probability, we double counted the intersection so that we subtract the intersection once. What was the P of B? 3, 6. What is P of C? 2, 6. And we found our intersection, probability of B intersection C, which is 1/6. 3 plus 2 minus 1 divided by the common denominator 6. 5 minus 1, 4 over 6. 2 over 3. Right? Okay, this is the end of problem number 3. Let's see, here we have problem number 4. Okay. Information on the weight and years of experience for a football team was obtained. The given contingency table provides a cross-classification of those data. Compute the following probability. So we have this table. The first column, weight, right? The first row is showing the years of experience. Problem number 1. Find the probability that a randomly selected player is a rookie. So, here, randomly selected player, there is no condition, right? A randomly selected player is a rookie. Then how many rookies do we have? 12, right? 12. So probability of a randomly selected player is a rookie. And we have 12 rookies out of how many? The total, this is the total, right? 60, right? You can simplify it to 1/5. Second problem, find the probability that a randomly selected player weighs under 200 pounds. Okay, let's see if there is any condition. Again, the subject is a randomly selected player, right? So, probability that a randomly selected player weighs under 200 pounds. Under 200 pounds, right? Then how many people weigh under 200 pounds. Right here, under 200 pounds, the total is 10. 10 out of how many? The total 60. You can simplify it to 1/6. Find the probability that a randomly selected player is a rookie, given that he weighs under 200 pounds. And here, usually, like the condition is given with the word given that, right? Given that. Or as an adjective for the subject. So we are going to see it in the next problem. So let's look at this. Given that he weighs under 200 pounds. So if we write this, probability that a randomly selected player is rookie. So this is my interest, whether the person is a rookie or not, under the condition that this is given that this is the condition, under 200 pounds is the condition. Based that the person is under 200. Then we have to find how many people are rookies out of people with under 200, right? Out of people who weigh under 200. Okay, so first we have to find how many people weigh under 200. Under 200, 10, right? 10. So out of 10, how many people are rookies? 4, right? 4 out of 10. So you can simplify it to, oh, you cannot see it well. 2 out of 2/5, right? Find the probability that a randomly selected rookie weighs between 200 and 300 pounds. So here, what is my interest? My interest, how many people weigh between 200 and 300, right? So my interest is here. And where is my condition? This is my condition, the condition. So between 200 and 300 out of rookies, right? Then first go to the column here. How many rookies do we have? 12. 12. Out of 12, how many people weigh between 200 and 300? 8, right? So 8 people weigh between 200 and 300 out of 12, right? So this is the end of problem number 4. Number 5. Problem number 5. Suppose that the length of a newborn seal pup follows a normal distribution with a mean length of 29 inches and a standard deviation, 1 inch. To find the probability that a randomly selected seal pup will be between 27 inches and 30.22 inches long, follow the steps below. The first problem. Draw a normal distribution and shade in the region of your interest. So this kind of problem, you have to start with sketching your normal distribution. First, normal distribution is symmetric, bell-shaped, and it has one mount, right? Bell-shaped, symmetric, pretty much like this. And you have to mark where's the center. Center is the mean, mu, which is 20. Oh, no, where is it? 29, right? 29, here. This is mean length of 29, right? And standard deviation, 1. Here is my mean, and standard deviation, 1 inches. And I want to find the probability that a randomly selected seal pup will be between 27 somewhere here, 27 and 30.22. Then you can say 27 is left-hand side of this mean, right? And 30.22 is bigger than 29. And I want to find the probability that your variable x is between 27 and 30.22, right? I want to find probability that x is between 27 and 30.22. To find this probability, we are going to use this table. To use this table, I have to find corresponding z-scores, right? Right. So second problem, find the z-scores of the two values 27 and 30.22. The first z-score, how can I find z-score? Z equals x minus mu divided by sigma. Here mu is 29 and sigma standard deviation is 1. My first variable is 27. 27 minus mu, what is mu? The mean, 29, right? Divided by standard deviation 1, which is negative 2. So I have found the first z-score corresponding to 27, right? Second z-score, the second x value minus mean divided by standard deviation. The second x, my second variable, 30.22 minus mean 29 divided by 1, which is 1.22. So then now I can say that the probability that the variable is between 27 and 30.22 is the same as probability that my z-score is between negative 2 and 1.22, right? Okay, now let's find the probability. Oh, but we have to make sure that this table gives you the probability, the cumulative probability of normal distribution, but this one is standard normal cumulative probability, meaning that if you have your z-score here, this is your normal standard deviation. Of course, the center must be 0 for this z-score and standard deviation 1, right? So it follows normal distribution 0 and 1. Well, this one follows normal distribution of 29 and 1, mean and standard deviation, right? Okay, so this table gives you the area, which is actually the probability. From where to where? From negative infinity to certain z. For instance, like my z is, let's say here. Then these numbers, here the numbers are the area under this normal distribution curve from negative infinity to z sub certain z. And these z's are right here. Okay, however, here I want to find the area between these two z's. Then how can I find the area between these two z-scores? You can split this probability into two. How? Probability that your z is less than 1.22 minus probability that your z-score is less than negative 2. What did I do? So what is this? This one, probability that your z is less than 1.22. Oh well, to do this, we can draw your z normal distribution. This is normal distribution of 0, 1, right? This is mean and standard deviation for z-score. Normal, standard normal distribution. The center is 0, the standard deviation 1, right? And the corresponding area for this probability is from negative 2 to 1.22, this. Okay, Then this one, probability of z is less than 1.22 is, again, from negative infinity to up to where? 1.22. And then this one, probability that z is less than negative 2 is this yellow part, right? So what we are going to do is that to find the area between this negative 2 and 1.22, we use this blue part and yellow part. And we subtract this yellow one from this blue big chunk so that we can find the area between these two numbers. Then now we can use this table. And let's find the corresponding probability, which is area. First, what is my first z-score? Negative 2. Oh, well, yeah, negative 2. Then go to negative 2 point. You can say this is negative 2.00, right? So negative 2.0 and then 0. So very first column gives you the first two digits of your z-score. And the first row gives you the second decimal numbers for your z-score. This is negative 2.00. Negative 2.0 and 0. 2.0 and 0. So you have found 0.0228 for this yellow part, right? Right, this yellow part. And then this one for the blue part, probability that z equals less than 1.22. Again, this table gives you the area from negative infinity to a certain z. In this case, 1.22, right? So 1.2 and 2. 1.22. So first two digits, 1.2, you can find it here, 1.2, and go to the second decimal number, 2, right? 2. So that you can find this blue part. Now what we can do is we want to find probability that x is between 27 and 30.22, which is the same as probability of your z-score is between negative 2 and 1.22. And you can rewrite this probability of z is less than 1.22 minus probability of z is less than negative 2. And we have found these two numbers. First one, this one must be bigger, right? As you see here, this blue part is bigger than this small yellow part, right? Which is, where is the number? The number is right here. 0.8888 minus P of z is less than negative 2.00, 0.0228. If you subtract 0.0228 from 0.888, you will have 0.8660. So you can leave it like this, or you can say, oh, this is 86.60%. Okay, so this is the end of the solution, and I believe you have got all these solutions very clear. Just in case you have any question, you can stop by in my office hour, Monday, Wednesday, Friday, 11 to 12, right? And I will see you guys on Friday, and enjoy your Wednesday. Bye!